Institute, and everything we do is undertaken on behalf of sewer network owners to help them address issues that they have and come up with solutions. So why are we presenting today on the subject of manhole rehab? Well, it started really 2 decades ago when German sewer network owners first were becoming aware that there were products available to help them rehab sewers, particularly in relation to issues concerning preventing infiltration. We did a little more work on something else that was of interest to them, which was odor control products that could be put beneath manhole lids in order to stop smells of getting out. But then our main research was undertaken from 2012 to 2016, culminating in a major study comparing the performance of different technologies that were available. And since then, we've been doing quality assurance field studies involving hundreds of manholes in the Netherlands and Germany, and running training on 2 to 5 day training courses. So what I'm going to talk about are 3 things: setting the scene of what happens with sewer manholes in terms of their primary and secondary functions, and then how we went about comparing the performance of rehab techniques, and finishing with some of the lessons that we learned. Well, what about sewer manholes? They are more than just a manhole cover, of course, which is what most people see. Down the shaft, they're actually possibly the poor relation of the sewers themselves. A lot of effort goes into keeping the sewers flowing, not so much effort into managing the condition of the manholes, although the obvious thing is often failure of the rungs which allow access, and you can see in this case they've been removed. Well, primary function is the relief of pressure internally, and of course when this is happening, this can cause damage to the interior of a manhole shaft. And another primary function is the accessibility, obviously for people and equipment to get in. So climbing technologies and equipment to stop falls and encourage occupational safety are important, as is concern for atmospheric measures relating to dangerous gases. And another third of the primary functions is ventilation, so allowing oxygen to get in, and unfortunately, of course, that does result in odor nuisance. There are a number of secondary functions. Of course, as a shaft, as a structure which is part of the sewer network, a manhole should not allow infiltration. And if you get uncontrolled water ingress, this can often result, for example, in the overloading of sewage treatment works, where too much volume of water is being received by them during periods when the groundwater table is high. And conversely, you can get exfiltration of sewage into aquifers as a result of damage to sewers. You've got to remember that apart from the chamber, you've got the seals which connect into the water supply, the pipes going in and out of the manhole. So another secondary function, it has to resist loads from above, from below, and from the sides, from the surrounding soil, etc., in order to correctly function. So any rehab does need to take that into consideration. And a final secondary function is there is a road safety issue, of course, with the manholes on the top. So what did we do about comparing the performance of rehab techniques? Well, the sewer network owners had started to realize that although they had these techniques available, various linings, they weren't always functioning properly. So they wanted to know which ones are suitable, what have they got to look for. And the exercise we undertook, which is an IKT compare or comparative project, was to look at, can you permanently make a manhole watertight by using a rehab technique? And they wanted to know what were the strengths and the weaknesses of the technologies that are available, what quality to expect, what issues to look for. We were required to undertake a 1-to-1 scale evaluation. And the whole project was funded by the Ministry of the Environment for North Rhine-Westphalia, which is the largest of the German landers, and a group of 17 of the cities which own the sewer networks, who formed the project steering group. Now, we have a procedure that we follow with these comparative projects. We've done them for sewers, lateral connections, lateral sewers, the manholes, flowable backfill, a whole range of products. We always start by working with the sewer network owners to understand exactly what the problem is that needs to be resolved. So we looked at the real situation in the field, and that involved going out with the members of the steering group and looking at their manholes and working out with them what's the actual problem they want to resolve and what are the causes. Something that also became clear was that there are many different types of materials used for manhole shafts. So we've got here concrete and masonry, a range of plastics, stoneware, and some combinations. And what was realized was that in Germany, the majority of manhole shafts are concrete. Then it's masonry and relatively little plastic. That's relatively new, the concept of using a plastic manhole shaft. So it was decided by the steering group the focus would be on concrete shafts. And we then undertook a market survey of standards, but also the available solutions, available technologies. What was out there that was available to them to undertake rehab and that needed to be compared. So we came up here with, essentially they fell into three technologies: mortar coatings applied to the inner surface of the manhole rings, plastic coatings, which could be sprayed on, for example, or applied in various ways, and then linings. These are more physical linings where you are bolting together or inserting something which is creating a new chamber within a chamber. And there were a number of representative products within each one of these technologies. So we were comparing technologies using a selection of representative products. So for the one-to-one scale rig, we use the large test pit at IKT. This is 15 meters long, 6 meters wide, and 6 meters deep. And we built a number of manhole chambers or shafts using new materials, but with simulated damage patterns. Once these were built up and the whole pit was filled with sand, it looked like this. And when the suppliers of the rehab techniques came to do their rehabilitation, this is what they saw, and they had a proper manhole to work through. A couple of extra things to point out in this photograph, which are typical of the projects we do. We do undertake a bit of research as well. So there were a couple of rectangular shafts were introduced as well at the request of a Dutch participant in the project, because they wanted to see how the spinning spray heads worked in terms of getting an even spread into a rectangular shape rather than a round manhole. And also, I mentioned before plastic manholes. Well, there was an interest in do these things float? If we fill this with water, because we have the ability to fill this sand-filled chamber up with water to simulate groundwater, did the plastic manhole float as a consequence? Well, having decided upon what the one-to-one scale evaluation would be like, we had to come up with a scoring system. And what happens in most of these exercises we do, we score according to performance, but also quality assurance. What sort of QA systems were in place by these suppliers. So in this case, the performance or system tests were given a weighting of 85% and the QA 15%. And looking down with the system tests, water tightness was considered to be the most important, so that scored 40%. The load bearing strength of the product, 20%. The robustness of the system, 20%, and acceptance. Now, this acceptance impression was actually because the steering group members had commissioned the work. They wanted to have a bit of a final say in whether they accepted what had been done. So this was based upon their impression when they saw the completed products. On the QA side, we look at a range of things, the installation manual and procedures. If it's followed, does it mean you can do a proper installation? And the technical data sheets for the products that we've been used. We wanted to know whether the contractor staff had been trained and what sort of training was available to people who use this equipment and materials, and whether there were test certificates available, and what sort of external monitoring or monitoring program did the contractor have in place to ensure that what they installed was done correctly. And finally, we look out for anything conspicuous. So if there's anything that occurs during the evaluation that was not anticipated in advance but is considered to be significant, that gets a mention as well. So the test setup, here's looking in a sort of a cross section through it. We have a number of chambers that were created, and we have the ability to fill the entire test pit with water. So we can bring it right up to near surface level to simulate rising and falling groundwater. Now, I mentioned that we put in some artificial damage, and in conjunction with the sewer network owners, it was decided that there would be a series of holes. There will be a series of damaged ring joints where the rings that make up the manhole shaft were stacked upon each other. Some more extensive patches of damage with multiple holes. And also, because there was a particular interest, how do these products perform if the substrate behind has not been properly prepared? These are particularly for the ones which rely on adhesion to the wall of the manhole. We put on a mold release agent, which would mean effectively the product wouldn't stick. And these were just done deliberately to see what would happen. It's part of the experimental side of this exercise. So we selected these products, or rather the steering group selected them. And something to bear in mind is that when we do these projects, we invite the suppliers in to see the experimental setup and comment on it. If they say, actually, what you're asking us to do is something our product cannot do, we accept that. And it may be that they decide to continue anyway, but we don't include that in the evaluation because they declared that they can't fix that, but it may be done for experimental purposes. So they get a chance to comment on it, and we take that into account when we are devising the final experiment. But the other thing is they're given a tender document and they are paid. Just like it would be a normal installation, they are paid to come and install onto into the manhole chambers. And if they decline or they don't want to take part, that was also recorded and included in the project report as the reasons why they didn't want to be part of it. So they came and did their installations, and we observed the installations, what quality control was involved, and it also gives some indication of costs, manpower, and the relative amount of time involved for using different techniques. The evaluation, having done the installation, I mentioned we can bring the groundwater up and down, was that we looked at the initial state. What was the product like, and how does it perform with no groundwater pressure when first installation. We then did a filling exercise in steps from 1 up to the full 5 meters, and looked a short-term exposure to heavy groundwater at a depth of 5 meters to see how they performed at that point. They were then subjected to a 2-month period of that high groundwater and evaluated again. At one point, the contractors were invited in. If there was some small damage which was visible, they were given the opportunity to fix that, so we could see how their repair might perform, the sort of thing that might be required after an acceptance evaluation. And then at the end, the water level was lowered, and we looked at the overall situation with those products. Now, in terms of when we were doing these evaluations, we looked at a whole range of aspects. So we had optical condition, so cracks, holes, color differences, the types of things you could easily see. An acoustic evaluation, tapping, listening for hollows, etc. A haptical evaluation, which was looking really at surface roughness, sanding, scratch resistance of the material. We did look at odor, because essentially if these things smell really badly and that smell is going to transfer out of the manhole and cause upset for the public, then, or be an issue for, let's say, for health and safety, that had to be considered. And as I was saying, overall, we were looking to see if there was physical leakage visible. We did adhesion tests to see if they would pull out, and we also did some wall stiffness tests using something called the MAC extensiometer. Sort of things we found. So here's the mortar linings, damp patches, cracking, issues around the footsteps. That was a particular thing we were interested in, as to how these products could cope with the ladder arrangement or the step arrangement within a manhole, and actual leaks. And if we look again at the plastic, we had one system that failed. It actually came away from the wall and bowed out under water pressure, so it was impossible to actually get down to the bottom of the manhole. This was essentially unsafe. We got the small leaks, we got bulges, and again we did find some issues around how they could cope with the steps. Again, this is the sort of thing that might require going back to have some further work done at a later date. And I mentioned a number of other tests. We did the pull-out test using devices to check the adhesion to the side for those systems that relied upon bonding to the wall of the sewer pipe. And this extensiometer applies pressure, and we can monitor movement to see what sort of strength is created by the lining system. I mentioned the project steering group had a say. They went down into each one of the manholes, they had a look themselves, and they were able to comment on anything that they felt would be of concern for them if they were accepting this as a completed project. We also, because we like to check what we see in the lab when they do an installation, is that the same as for real? We will go out and look at real installations of the same products. Well, the results are tabulated, and you can there's some links at the end to show you where you can get hold of these. We score the system test, the performance, and the quality assurance, and there's a lot of other information. Too much detail in here for me to explain, other than to say that we score from 1 to 6. 1 is good, 6 is bad, and we had a range of good to satisfactory here. And on the second page, we got down to one which is barely sort of sufficient or adequate, and down into not evaluatable. That was the one that failed. So what lessons did we learn from this? So first of all, we did learn that you can get reliable rehabilitation of a manhole shaft against groundwater pressure from these systems. Not all of them, but there are systems out there which will work in that way. We had a range from very good down to adequate. What was very clear was that in most cases where we did see a problem, it was deficiencies in substrate preparation. This was in the field, but also with those simulations we did. So if you don't have good preparation of the substrate and the material can't bond, then you may be you will result in problems. We also found that if there are problems, they will appear immediately. What we tended to find was that when we raised the water table, we would see damages appearing, and they might get worse over time. But what we tended not to see over time was anything new appearing. So that has lessons for inspection. So what we recommend is, on acceptance, a product is inspected when the groundwater level is high. So it might have to wait to a wet season to do a formal inspection. The load-bearing capacity using that MAC system varied quite widely. And we got a whole range of things from relatively deficient to excellent. We found in some cases there was no structural analysis certificate that could be provided for the product, so we didn't really know what the load-bearing safety information was for it. And in fact, quality assurance tended to be very patchy. And the majority of the system suppliers, they weren't able to provide training certificates or testing certificates or approvals. So there were some issues there. And we did do this Mac extensiometer with some sort of crack rings to see what would happen. We got a range of overall stiffness. We found the plastic coatings that the stiffness was a bit lower, but a combination of the plastic with what was left of the surrounding rings did return the original stiffness of the concrete. And the final sort of overall, once again, to say is poor substrate preparation that we believe would be the thing that was most likely to let down a system like this. So that ends the presentation. There's a summary article available in English, and there are full reports available in German online. IKT, we publish all of the work we do in the public domain, so you can find it there. There's a couple of websites, and there are the contact details for myself and Marcus Gillar, who was the project manager. So thank you very much for this opportunity to make the presentation,